Excuse me, how embarrassing. You caught me coming out of the restroom. But hey, it's a fact of life. We humans have to use the bathroom to rid our bodies of the waste it produces. Have you ever wondered what happens to the water after you do the dishes, take a shower, or flush the toilet? Probably not. I mean, who really wants to? I'm Kim Combs. The process of treating wastewater and returning it to the environment has many steps. It's a mixture of chemistry, physics, and biology, all working together to produce something we might take for granted, safe water. Let's learn what chemistry's got to do with it. The whole process begins in the home. Wastewater leaves the home in many forms: water from dishes, laundry, bathing, and as mentioned before, human waste. Wastewater leaves your home through a small pipe that connects to a larger pipe. That larger pipe receives wastewater from many homes in your neighborhood. All this wastewater flows downhill by gravity toward a wastewater treatment plant. At some point, the pipes have gone as low as they can, and then pumps are used to push the wastewater up to an elevation where gravity takes over and the wastewater can once again flow downhill. This process continues as needed all the way to the wastewater treatment facility. Once there, the process of turning wastewater into environmentally safe water begins. Terry Estridge works as a technician at a water treatment plant.
One of the first processes in a wastewater plant is a screening process. In a little or a lot, almost everything finds its way into a wastewater plant. This screen has 1-inch openings down at the bottom that will capture any big debris, such as logs or sticks, large rags, anything that would damage equipment downstream. We try to remove in the screening processes. And this is grit removal. Grit such as sand, cinders, eggshells, coffee grinds, anything gritty like that that can be abrasive is removed at the beginning of the wastewater treatment plant process, because that debris can wear on equipment, be abrasive, and it can also use up valuable tank space. So this is our grit removal process. There's different types. There's forced vortex, velocity controlled, and what you're looking at here is aerated grit removal. Air is injected and it creates a bubble pattern, and the grit is forced to a channel in the bottom of the tank to where these bucket conveyors will operate and remove the grit from that channel. And these are called primary clarifiers or primary sedimentation tanks. Screenings was a physical type of treatment. Grit removal was a physical type of treatment. And primary clarification here is also a physical type of treatment. What we do is we slow the wastewater down enough to where settleable materials will settle and readily floatable materials will float. We slow the speed of the wastewater down to about 1 foot per minute in this process. The material that settles to the bottom is called sludge, and is scraped to the middle and removed by a pump for further treatment. The material that floats to the top is called scum, and it's removed, and it's also directed to further processing. After primary settling, the effluent from the primary settling process is directed to this process, and this is called aeration or activated sludge. And this is where we switch from physical treatment to biological treatment. You can't slow the wastewater down anymore to settle out any more materials. The capital cost for building tanks that big would just be too cost prohibitive. So a typical wastewater plant has a biological treatment process. It can be attached growth biology, which would be like trickling filters or RBCs, or it can be a suspended growth biological treatment system like this is, activated sludge. And in this tank we add oxygen, and here's where we accumulate bacteria then that use the waste and the wastewater as their food and produce carbon dioxide and water as byproducts. This is the final clarifier or secondary clarifier. The activated sludge at the end of the aeration process is directed to this tank, and the mixed liquor, which is the contents of the aeration tank, it's called mixed liquor suspended solids, it settles out in this clarifier. And at this point it should be mostly all bacteria, because the bacteria should have eaten or have assimilated most of the waste in the wastewater. So when the bacteria do settle in this tank, we pump them back to the head of the aeration tank because they're like hungry again and ready for more waste from the primary treatment process.
Okay, so far in the attempt to make wastewater environmentally safe, we've used both physics and biology. Sure, the water is cleaner, but not clean enough to return to the environment. It's time for chemistry to get involved and finish the cleansing process.
You're looking at pumps that deliver chemical to the wastewater. This is the last process before it reaches the river. We've removed a lot of pollutants at this point, but there's still some bacteria that could potentially be pathogenic, so we have a disinfection process. You can disinfect wastewater with ozone, ultraviolet light, chlorine, and that's what we use as a type of chlorine. We use sodium hypochlorite, which is a real strong bleach, about 12 to 15% chlorine. So these are the metering pumps then that deliver that chemical to the wastewater flow for disinfection. On the other side are pumps that feed sodium bisulfite. After chlorine is in the wastewater for a while and done its disinfection, the EPA requires us to remove the chlorine. So sodium bisulfite then is added after chlorination to remove the chlorine before ultimate disposal to the river. This is the tank in which the chlorine is given time to react with the wastewater to destroy pathogenic bacteria. Pathogenic means disease-causing. So you provide at least 30 minutes of contact time for that to take place. The last section of this tank, you'll see air is added. That's post-aeration. One of the requirements that the EPA requires is that we maintain at least 7 milligrams per liter, or 7 parts per million, however you want to look at it, of dissolved oxygen in the effluent. So we add air at the end of the process to ensure we're above that 7 milligrams per liter before it hits the river. That's our effluent. For ourselves and for the EPA, we're measuring all kinds of parameters in the effluent as it goes out. Measure for temperature, pH, chlorine, turbidity, dissolved oxygen, ammonia. So this is where we monitor the effluent before it goes through the river.
And here it is. Water once full of waste and contaminants returns to the river environmentally safe. It's hard to believe that water that once looked like this now looks like this. I'll bet you think the process is complete, right? Well, it's not. Remember all of those solids that were removed in the clarifying ponds? That waste all has to go somewhere.
Okay, we're in the sludge dewatering building right now, and we just saw the effluent that goes to the Scioto River. But in treating that wastewater to get to that point, we generated some residuals, or sludge. And that sludge also needs to be processed. Here, the sludge is dewatered from a liquid, about 5%, similar to a milkshake, to about 26% total solids, which means 74% water. So we remove a lot of the water out before it goes to a subsequent process. And the cake sludge kind of looks like soil. It'll either go to incineration, or it'll go to a compost facility, or rarely it goes to a landfill. This is called a multiple hearth furnace. So there's 8 different hearths. That ravel arm will ravel the sludge around to a drop hole, and it'll go to the next one, and it'll ravel around and drop. It's all burned up by the 3rd or 4th stage.
Would you ever have imagined everything that goes into taking your wastewater and returning it environmentally safe back to a river? Americans use an average of 379 liters of water per person per day, and nearly all of that goes through a water treatment facility before it goes back to a river. So next time you do this, or this, think about the effort and science that goes into keeping our water clean. See you next time.